In this video, I'm going to show you how to determine whether two events are independent or not independent. Two events are independent when one of the events occurring does not change the probability of the other event occurring. We have two examples of two-way frequency tables. The one on the left is an example with two events that are independent, and the one on the right is an example with two events that are not independent. Let's start with the independent events. This two-way table is giving us information about whether or not somebody likes chocolate and whether or not they have blue eyes. Now, just using our prior knowledge, it makes sense that these events are independent because your eye color probably does not impact whether or not you like chocolate. The first question is asking us to find the probability that somebody likes chocolate. Since we're looking at anybody in the table liking chocolate, our denominator is our total number of people in the table, which is 120. Then we need to know the total number of people out of the 120 that like chocolate. So I go to the likes chocolate column and down to the total, which is 75. So my probability that somebody likes chocolate is 75 out of 120, which is 0.625. Now my next probability statement, I can see just by looking at it that this is a conditional statement because this line in the middle I know represents the word given. So I'm being given a condition here. I'm looking for the probability that somebody likes chocolate given that they have blue eyes. So remember that the condition always comes after the given. So my condition is that I'm only looking at people with blue eyes. So to do this with the table, I'm going to use my circle and check method. So I need to start by just circling only the people that have blue eyes. So I'll go to the has blue eyes row and circle the whole row. And those are the only numbers I'm going to use to find this probability. Now, since I'm only looking at selecting someone with blue eyes, my total in my denominator is the total with blue eyes, which is 48. Then I need to know the number of people that like chocolate and have blue eyes. So I go to the likes chocolate column and I'm still just staying in my has blue eyes row, and I see that I have the number 30 in that corresponding box. So my probability is 30 out of 48, which is the decimal 0.625. You might already be noticing that this is the same answer we got in the last question, and I'm going to come back to that and explain why we got the same answer. Now, before we do that, let's talk about the not independent events. The events in this table are whether or not somebody gets an A on a test and whether or not they studied for a test. Just by thinking about what these events mean to you, it makes sense that they're not independent. Most likely, whether or not you study is going to impact your grade. So the events probably are not independent. It makes sense that they're labeled as not independent. So the first question asks the probability that somebody gets an A on the test. So since I'm looking at anybody in the table, my denominator is the total in the table, which is 120. And then I need to know out of those 120, how many got an A. So I go to the gets an A on a test, down to the total, which is 90 out of 120. And that is the same as the decimal 0.75. Now, I have another conditional statement. Remember, this line tells us we're talking about a given statement. So I'm looking for the probability that somebody gets an A given that they studied. So my condition is I'm only looking at people who studied for the test. Once again, I can do my circle and check. So I'm going to circle the row of only people who studied for the test. The total number of people who studied for the test is 67. And then I need to know the number of people that got an A and studied. So I stay in that row and I go to the gets an A column and I have the number 55. So my probability that somebody gets an A given that they studied is 55 out of 67, which is 0.82. All right. Now, notice that for the independent events, we got the same probability for the two questions, and for the not independent events, we got a different probability. This makes sense. Think about, first of all, with the not independent events. If you get, the probability that you get an A is 0.75, but the probability that you get an A given that you studied is 0.82. It got higher. And that makes sense because most likely the people who studied are more likely to get an A because these events are not independent. They can impact one another. On the independent events, we know they're independent, so they're not impacting one another. So for the probability that you like chocolate, it's 0.625. The probability that you like chocolate given you have blue eyes is still 0.625 because your eye color is not going to change the likelihood that you like chocolate because they're independent. So we can confirm that two events are independent if the probability that the event A occurs is equal to the probability that event A given B occurs are the same. So we know two events are independent if the probability that one event occurs is the same even when there's a given condition.